Hello everyone. Uh, Welcome back to Home Coded Meal. So before starting this new topic on the new video, I hope you have seen the previous video where I have explained basics about what a programming language is, what does machine understand, what is machine code, what is bytecode, and basically Python architecture. How does Python execute the codes? Okay, so what happens internally when you execute your code? Okay, I will just go in brief of what I have discussed in the previous video. So if you haven't watched the previous video, please watch it. Okay, because in this video there will be some of the concepts will like which will require basic understanding of whatever we discussed in the previous video. For example, bytecode, interpreter, etc. Okay, so let me just revise what I discussed in the previous video. So people who are new, like, subscribe and all the like what we do on YouTube, like and subscribe the channel. And the people who are coming back, let's just revise once again. Okay, so we revised what is programming language. Okay, we understood what is programming language. Simply, what is programming language? What is programming, so to say? Programming is or what is a program? I mean, too many questions are coming. But what is a program? Program is a set of instructions, okay, that you give to your computer. Now, the language in which you write those instructions is called programming language. Okay, what does machine understand? Machine understands only one type of language, which is called machine language. It can also be called machine code or object code. The nature of the machine code is numeric, and this code is expressed in binary. What is binary? Binary Binary is basically binary numbers are combinations of zeros and ones of base 2. That's a binary number. Okay. Huh. Okay. So let's take an example of what is the difference between a binary number and a decimal number. Okay, so a decimal number comes with a base of 10. What is this base of 10? You will actually need to understand different types of number systems. There are different types of number systems like decimal, hexadecimal, binary, octal. Okay, so they have different types of bases. Normally, the decimal, the integer numbers that you use in your daily life, that you have been learning from your school, 1, 2, 3, 4, etc., are this decimal number with a base of 10. I will actually make a separate video of how this number system works, but for now, there is something called as base 10, which is what we use in our daily life, and the binary number has a base of 2. That is why this 100 is not same as this 100. Here, the value of this in decimal is 4. Here, it is 100. Okay, just keep this in mind. What is binary number? Binary numbers are made using combinations of zeros and ones with a base of 2. Okay, let's continue. Just 1 second, let me just see. Hello. Yeah. Okay, so let's continue. Uh, Basically, programming languages are language, you can call it syntax or grammar, that is understood by humans who can write instructions which is later converted into machine code. Okay. Uh, I hope people who are new to this video or this playlist or even this channel as a whole, please go and watch the previous video where I've explained all this in detail. Okay, some of the examples of programming languages are Python, Java, and C. In Python, very simple syntax is followed. If you want to, like, one of the examples of code is actually print hello. Okay, you will actually, if you are, if you have just graduated from high school and going and joining a college or university, something like programming languages, syntax, structured programming approach will be there in your curriculum. Okay, so there you will come to know these types of syntaxes. Print hello, and this is the syntax for Python of printing anything. C has a different syntax, Java has a different syntax. But let's move on now. Okay, so next we discussed CPython. What is CPython? Python, first of all, is an interpreted language. Okay, there are two different types of programming languages: interpreted and compiled. A language which is an example of compiled language is C. Okay, C is a compiled language. What compiled language actually does is that it takes a source code and directly converts it into the machine code. Okay, what is machine code? Again, I'm expressing this again and again because it's very important. What is machine code? Machine code or machine language, it's just a language that is understood by our hardware machine. Okay, it's typed like this sequence of ones and zeros. That's the machine code. So what a compiler language does, it takes your source code, directly directly converts it into the machine code. But this same procedure is not followed by an interpreter. Python is an interpreted language, or so-called interpreted language. Conversion of Python source code into machine code happens differently. Okay, let me just revise how. Again, I'm emphasizing this. If you haven't watched the previous video, go and watch. Stop right now and go and watch because I've explained this in detail there. So, but let's carry on. So, Python has an intermediary stage called bytecode. So, your source code is first converted into bytecode using an interpreter, which is called CPython. Okay. Uh, Sorry, my bad. Let me just backtrack there a bit. Bytecode stage is actually done in a compilation stage. Okay, it basically checks your syntax. It checks whether there is any grammatical mistakes and etc. And then a Python compiler. Python also has a compiler. It's not a pure interpreted language. Okay, so Python compiler is responsible to convert source code into bytecode. What is bytecode? Bytecode is a low-level platform independent representation of your source code. I think this statement is pretty self-explanatory. What is happening here? What is bytecode? Bytecode is not machine code. Okay, so if you directly provide your machine with bytecode, machine hardware will not understand what you are trying to say. So don't confuse between them. What is bytecode? Bytecode is a low-level platform independent representation of your source code. That is simply what is meant by bytecode. Okay, it is actually after a generation of bytecode using the compiler. It is the code is actually given to something called as Python virtual machine, which actually interprets the bytecode. What is an interpreter? Okay, if you want to ask what is an interpreter is just someone who converts one type of language into another type of language. Like the name interpreter is pretty self-explanatory. What is interpreter? Take something and translate into something which the other party can understand. Now, one party here is you as a human, and other party is your machine. What interpreter is doing, taking your code, basically bytecode, and converting it to the machine code. That is the whole duty of PVM. So here is a flowchart which makes you understand. First, the initialization takes place, which will generate the bytecode. Here, the compilation takes place. It will check all your grammatical errors. If there are any grammatical errors, it will stop in the middle and ask you to basically correct the grammatical errors. It will show you where the errors it faced, and after that, it will proceed. It will pass the code to PVM. PVM has a C Python. There are other interpreters as well, but the C Python is most commonly used. C Python will convert the bytecode into machine code, and that's what the CPU actually understands. So there are different uh, There are different abbreviations of times, or I don't know what is this exactly, but something it is called. So in generation of byte code, the time required to generate the byte code is called compile time, and the time actually required by the hardware or the CPU to actually execute your instructions is called runtime. Keep this in mind. Let's continue. What are modules? Next thing we discuss are modules, because Python is a modular type of language. The whole source code of Python is actually distributed into tons and tons of modules and libraries. Okay, unlike some other programming languages, or basically which are used for functional programming, Python does not actually have a long list of functions. Because let's say, for examples, you are writing a book. Okay, if you're writing a book, you have either two options: just have one chapter and write everything in bullet points, or divide everything into chapters. Python divides everything into chapters. Every single chapter has a different function or different thing to do. So basically, syntax is something like this: import your module name, etc. But module is actually dividing your code into different functions. Basically, module is another Python file which you can import into another Python file and use all its variables, functions, methods, classes, etc. We will actually deep dive later into what I meant by modules. In this video only, I will show you how you can import and use modules. Another thing we discuss is that Python is a dynamically typed language. What do we meant by dynamically typed language? I'm strongly emphasizing, for you to understand this whole thing, go and watch the previous video. But for a brief, dynamically typed language. So what is a typed language? Or in fact, what is typing? Typing means just checking what type of data type it is. If you initialized a variable, okay, so it means that it actually checks every equation, syntax, etc. of that for the data types. Okay, so there are two types of typing languages basically: strong type. Python is also strong type. So if you try to do this kind of stunt, this is a string. Okay, this is the character 1 plus integer 2. Python will give you an error because implicit conversions of data types are not allowed in Python. Whereas weak type languages, for example JavaScript, same example will return a string 1 2, because this thing which is not allowed in Python, it is allowed in JavaScript. Understood? Now why dynamically, or why dynamic? Dynamic means doing this type checking during the runtime. Okay, this type checking does not happen during the compile time. When type checking is done during the compile time, it is called static. Dynamic means doing the type checking during the runtime. When is the runtime? Here is your runtime, when the machine is executing your code. That's your runtime. Okay, I hope you understand, but for now, let's continue. So today we will actually discuss some more theoretical concepts about Python. Okay, this might actually be sorry, like there is cold here, but today we'll actually discuss about performance implications of Python. Because in the all the previous videos, I have actually discussed about advantages of using Python. There are tons of advantages of using Python. Now I remember that I never discussed what are the drawbacks. Okay, why some people choose different languages over Python, because not everybody goes for Python. So today we will discuss performance implications. One of the main drawbacks of using Python is execution speed. Yep, you might have been coming across this a lot. that you might have been coming across this a lot, that there is some issue regarding the execution speed of how Python. I mean, even if you go on web, Instagram, etc., you might have seen that there are something. Some of the people are telling that Python is slow. Python is slow. Why are they telling that? Okay, and with respect to what Python is slow, right? If you say something is slow, it has to be with respect to something, right? If I say that you are a fast runner, but with respect to what you're a fast runner? Are you faster? Are you a fast runner with respect to Usain Bolt? I mean, there needs to be something reference. So Python has a slower execution speed. So Python has a slower execution speed with respect to compile the languages. So what are compiled languages? I just discussed with you. Compiled languages are the languages which convert source code directly to machine code without any intermediary step between them. Hence, they are a lot faster. Some of those examples are C and C++. You might be learning this or might have already learned this or whatever. Python is slower than these two guys. There is a pretty easy example of why this happens. Okay, so people who have actually used a lot of C and C++ and now they're jumping into Python, they might actually see some of the differences of how we write Python code. Okay, because they already have a background of C and C++, so obviously there will be some differences that everyone will notice. So in Python, when you write a source code and you tell it to run the code, it automatically runs. How it actually runs? How it actually runs, I just showed you. This is the process of how the Python code is running. Very simple flowchart. How basic execution of Python code is done. This is the flowchart. Initialization, generate the bytecode during the compile time, checks for syntax errors, etc. Forwards this bytecode to Python virtual machine, which has an interpreter of C Python. Okay, it's a Python interpreter written in C language basically. Now it interprets all the bytecode and converts it into machine code, which is executed by your CPU during the runtime. That's the basic thing, how Python code is executed. Okay, so but for a detailed explanation, watch the previous video. Now, but we know that bytecode is not the machine code, right? Let me just type this again so newcomers can also see. Bytecode is not the machine code. So CPU or your hardware cannot execute the bytecode itself. Okay, it does not understand what a bytecode is. It only understands binary code, zeros and ones, which is the machine code. So the reason Python is slow because Python has to convert this bytecode into machine code. This conversion takes time. More the complex instructions you give, more time Python will take. The larger instruction you give, more time Python will take. The larger types of calculations you give, more the time Python will take. For example, if you want to, one of the concept is like cost of operations. Okay, so if you are adding two numbers, 1 plus 2, and let's say if I give it some cost, or just forget it. Okay, 1 plus 2 will have a less cost as compared to, let's say, 3 raised to the power 6, or even 3 multiplied by 6. 3 multiplied by 6 is much more costlier and requires more time as compared to 1 plus 2. So addition requires less time as compared to multiplication. Division will require more time as compared to subtraction. And this is just one of these operations I'm talking about. there are lots and lots of operations that you can perform. You can make your own if you want, like a series of multiplications, additions, logarithmic, some other scientific trigonometric calculations, etc. It will take time to execute. When you do this in C language, all of that source code is converted into machine code directly via the compiler. But in Python, that source code first gets compiled into bytecode, then the bytecode is interpreted by the C Python into machine code. It's like a three-step process. This takes time. And that's why Python is slower with respect to compiled languages. But Python is not that slow. There are some programming languages which are completely interpreted because Python is not 100% interpreted. It has a stage of compiling as well. Because the compiling stage, that's how the bytecode is generated in the first place. So Python lies somewhere in the middle. But generally, Python is slower than C and C++, or basically any compiled languages. Okay, so Python virtual machine is still required to interpret the bytecode, which requires more time. And Python execution speed of Python is not very slow, but somewhere in the middle. But there are some cases where you need faster execution speed. Okay, now before moving forward, I just want to enlighten you about the significance of this video, because the concept that I'm going to explain, you might not come across this concept in your college. Okay, I'm not bragging or anything, but you might not come across this in your college because I haven't. And the significance of this might be because after your graduations, or if you have already graduated and you're doing some, you have some future plans to pursue further studies or anything, etc. These concepts are actually good to know. Why is it good to know? Because we are actually discussing here what is called um, performance implications. Okay, so we are discussing performance implications of Python. So here this video will be completely on how can we increase the performance of Python. Basically, how can we increase the execution speed of Python. Where this will be most useful, it will be most useful in research, space research maybe, scientific calculations. So if you want to pursue your career in data science, machine learning, deep learning, artificial intelligence, one thing you need to be well versed with is calculation, numbers, statistics, right? So data scientists are good statisticians. They have a good analytical ability. But when you go into the field of data science, you will actually see that you actually have to rely, majority of the time, you have to write less code, and your most of the time will be spent on thinking of how you can improve your code or your model. So if I divide your project in out of 100, like 70% of the time you'll be thinking how you can improve, and 30% of the time you'll be implementing what you thought. Otherwise, you will just open your laptop and sit for 2 hours doing nothing. In fact, for the 2 hours, you will be thinking what to do. That's why this video is very important. Performance implications of Python is very important when you go into analytical fields, especially because there you need faster calculations, you need better models, you need the models to train faster. There might be some time constraint. You might have some time constraint that your model needs to evaluate certain parameters within a couple of seconds. and generally using C Python interpreter might not be up to the mark. So there are alternatives. Now let's discuss that. I hope it's clear what are we discussing in this video. Okay. So as I was saying, Python is slow than C and C++. But how we can improve this thing? So as I was saying, a concept that you will generally not come across while you are in college, it is called PyPy. What is PyPy? So PyPy is a system. Okay, it's just another standard C Python. Okay, okay. It's standard C Python re-implementation. Okay, it's just an interpreter. First of all, it's an interpreter. Let's get that clear. It's an interpreter, and it's a re-implementation of an interpreter that is widely used in Python, which is C Python. But this is focused on performance. It is solely focused to increase the execution speed or to provide better performance with the same Python source code, right? So how does it do that? How does this PyPy work? Basically working, yep, let's keep it short and simple. How does this PyPy work? It's very simple, okay? It uses a concept which I will explain you shortly, but have you ever wondered why haven't you heard about PyPy? Like, I can guarantee people who are already working in Python or who have maybe like fresh experience in Python might have heard somewhere or something about C Python. Like might have came across. But have you ever came across PyPy? What is PyPy? So I'm not actually sure how many people are using PyPy because there are also alternatives of PyPy. But no, most widely used is C Python. So PyPy actually does have some complications and integration issues due to which it is not as widely used as C Python. And most of the time C Python does the job, so you don't actually need to worry about, but it's still good to know. Okay, so now let's understand working of PyPy. How does PyPy work? How does it speed up everything? I will also explain this you using a flowchart, so don't worry. So whole existence of PyPy is for performance, just for performance. पैदा ही हुआ है performance के लिए. Okay. Uh, I would actually at this point I would actually recommend you using Google, or maybe if that's not your favorite web browser, like search web basically. Okay, I will actually encourage you go to the web, search PyPy, what is PyPy, and get a detailed answer of what is PyPy. In fact, let me just do that right here for now. Okay. Let me see. PowerPoint. Yeah. Okay. So yeah, search the web whenever you want to. But now let's just understand. Okay, let's take it on the new slide. I don't want this, this. Yep. What is, okay, let me just type it for you. PyPy. Okay. So PyPy is a system, just another standard for C Python. Basically, it's re-implementation. Okay. It is why is it faster? It is faster because it uses just in time compiler, or basically JIT. Now, what is JIT, or just in time compiler? Have you ever heard of it? No, because this is the problem actually. Many people don't understand what's happening on the inside. They just study how Python works on the surface and thinks that okay, we are all good now. We understand what Python is, and yep, okay, now let's go into data science. What's just-in-time compiler? This is extensively used by Java. But what is JIT? JIT simply means just-in-time compiler. Okay, it's a if you don't understand, it's a kind of fancy word. But let's see. So what is just-in-time compiler? I'm pausing because at this point you should already have done a Google search. What is just-in-time compiler? But let's get into it. Just-in-time compiler takes the source code, basically your Python code, and transforms a lot of it or much parts of it directly to machine code. Okay. So what does, let me just make you understand using a flowchart. Insert shape. Okay. So understand this, like copy paste this again. This is your source code. So, and your source code will be in .py extension, and something happens and it gets converted into machine code, like most of the part. Okay, not complete source code. Most of the part gets converted into machine code directly, and then rest of the small part which are remaining takes its own time using the C Python compiler, sorry, C Python interpreter, and gets converted into machine code. But how does thing work? How does this thing work? What's actually happening in the middle? Try and understand this. Okay. So now you have your source code. Your destination is the machine code. How does PyPy interpreter actually works? So very basically, whatever we just understood here, your source code is first of all converted into bytecode. This happens like normally. Everywhere this happens. Uh, just one second, guys. Let me just get my charger. Okay, so I'll be real quick. Uh, Source code to bytecode using compilation. Okay, so I hope recording is still working. Yes, okay. And we are recording the same screen. Yep, okay. Real quick, source code to bytecode initialization step. I explained you in this flowchart. This initialization generating of bytecode during the compile time. This happens the same. But what actually happens here after this comes the PyPy interpreter. Okay, after this comes the PyPy interpreter, and it does something magical. Py interpreter. What it does, it takes the concept of just-in-time compiler. What the just-in-time compiler actually does. What's its role? Why are we talking about it so much? Think about it. Just in time, as the name suggests, what does just in time actually do? Just in time compiles the code, like majority of your code, directly into machine code, and it executes your code during the runtime. Did you get that? Just in time compiler. Okay, basically PyPy interpreter takes a lot of your code and directly converts it into the machine code, and the bytecode here which needs to be interpreted, the part of remaining bytecode, okay, it's actually done during the execution. Okay, so the remaining bytecode is converted into machine code during the execution. If you refer, if you refer this flowchart, here what we are actually doing was bytecode, give to PVM, PVM will interpret and then give to machine code is given to your CPU, which then executes it. What is happening here? Bytecode is okay. Till this process, it's completely fine. But after this thing is basically the same thing only. What PyPy interpreter is actually doing, first of all, it already converts a lot of your source code directly to machine code. Okay, let me see if I can. Lot basically a bytecode is already converted into machine code. Now this actually happens. I'm not sure if I can get. Okay, this actually happens during a runtime. I explained you what runtime is. Okay, and how does this thing work? This actually happens during the runtime. During the runtime or in the execution time, this bytecode is getting converted into machine code and at the same time getting executed. It's kind of like a pipeline type structure. एक तरफ से from one direction bytecode is coming in and from other direction machine code is getting out and getting executed. That's how PyPy speeds up this process. Okay, so I guess that's all you currently need to know about PyPy. If you want to know about more about, sorry, if you want to know more about PyPy, you can how helpful is actually this thing. Helpful is PyPy. So PyPy can actually speed up your Python programs by 7 times approximately in some cases. For some special cases, it can go up to 50 times. So that's a really good number. Okay, so you get faster execution of your Python code. So keep this in mind if you are planning or if you are thinking that your dream job lies in data science, machine learning, and etc. such fields, basically which involves a lot of scientific computing. You have to keep these are kind of concepts in mind. These are good to know. Another application of scientific computing where you will come across this a lot is algorithmic trading. Okay, basically algo trading. Algo trading does require faster calculation of numbers, faster forecasting, faster analysis of trends. Okay, so in algorithm, it's all about speed. It's all about speed. We require speed in algorithmic trading because in algo trading, the guy who cannot predict can win by speed. He can overtake the one who can predict. And if you have prediction speed, and God knows what you can do. But let's move forward. And now, today, we will actually see how we can execute our Python code. Okay, so I guess this is all for the PPT that you need right now. Okay, if you want, rewind the video and see and revise whatever you have missed. But we will actually go into now how you can execute simple Python codes. Okay, before even that, we do that. Maybe we can revise something. We can see what is bytecode. One simple question for those who forgot what is bytecode. It's pretty important to understand what is bytecode because it comes everywhere. Bytecode is lower level, platform independent. Did you understand what is bytecode? Bytecode is lower level, platform independent representation of your language. Extension of bytecode is .pyc. That's a byte. But now let's get started with Python. Writing code. Writing Python program. So I guess that's enough for the PowerPoint for this video. Okay, I will directly take you guys to code editor. Okay, so let me just close it. Okay, so let me see what we are not seeing anything. So